Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 5, Lesson 3 on the slope-intercept form of a line. Alright, so in the next few lessons we're going to be talking about equations of lines. And equations of lines, as you've seen both in 8th grade math and in Algebra 1, are absolutely critical to understand, to be able to use, to be able to plot, to be able to come up with the equations. And I'm hoping that what we do today is complete and utter review for you. So let's jump right into it. All right, the equation of a line. Because of the importance of lines in geometry, it is critical to understand how to describe the points on a specific line by using an equation that relates their x and y coordinates. So let's jump right in to exercise number 1. Consider the linear equation y equals 2/3 x plus 4. Now letter A says use your calculator to help fill in the xy table below. I'd like to save a little bit of time right now and actually not break out our calculator, right? The idea here is if I took x equals -3 and I substituted it into this equation and I did 2/3 times -3, I'd get -2. And then if I add it to 4, I would get +2. So the y coordinate for an x coordinate of -3 would be +2. Likewise, if I took 0 and I substituted it into this equation, 2/3 times 0 is 0, plus 4 would give me a y coordinate of 4. And I can just keep doing that. If I took 3 and substituted it in here, 2/3 times 3 is equal to 2. 2 plus 4 is equal to 6. So I'd just get 6. If I took 6 and I substituted it in here, by the way, I've chosen values of x here that are easily multiplied by 2/3. If I took 6 and I multiplied it by 2/3, I would get 4. 4 plus 4 is 8. And likewise, if I put 9 in there, 2/3 of 9 is 6. 6 plus 4 is 10. Now, of course, what that does then is it allows me in letter B to graph the line on the grid provided. In other words, each one of these represents a coordinate point, right? The point -3, 2 would be right here. The point 0, 4 would be right here. The point 3, 6 right here. 6, 8 would be right here. And 9, 10 would be right here. Yet again, did not give myself a ruler, so I'm just going to hand sketch a line really quick. And there's my line, y equals 2/3 x plus 4. All right, now let's take a look at letter C. Fill in the following based on the graph. The line's slope equals and the line's y-intercept equals. All right, well this is simple enough. Pause the video now and see if you can fill in both the slope and the line's y-intercept. Keep in mind, right, the y-intercept is the y-coordinate where the graph intersects the y-axis. Pause the video now and go ahead and do that. All right, well the line slope we can do graphically or we could do with the slope formula if you really wanted to, but it's very simple graphically, right? Here I have a change in x of 3 and a change in y of 2, so the change in y divided by the change in x would be 2/3. The y-intercept happens to be this coordinate, which is just equal to 4. All right, so last little piece, letter D. Circle the slope and the y-intercept in the equation of the line. See, this is really cool. The equation of the line actually contains the slope and the y-intercept. You can literally see them. Here, right, is our slope, and here is our y-intercept, all right? Which is why this form of a line is called the slope-intercept form of a line, because you can literally look at its equation and immediately see both the slope of the line and its y-intercept, the location where it crosses the y-axis. Let's summarize all of that by going to the next page. The slope-intercept form of a line. Let's take a look. The slope-intercept form of a line. A linear equation of the form y equals mx plus b describes the points on a line where m is equal to the line's slope, rise divided by run, or the change in y divided by the change in x, and b is equal to the line's y-intercept. All right. Now, what's of course cool about this is that once we have this, it then allows us to plot the lines pretty quickly and easily. Oh, good, I gave myself a ruler this time. Anyway, so let's take a look at exercise number 2. For each linear equation shown below, identify the line's slope and y-intercept. Then sketch the line on the grid provided, label each with its equation. All right, so let's take a look at letter A. Letter A is very easy, right? We have y equals -1/2 times x plus 3, okay? Keeping in mind that this then is the slope and this is the y-intercept. Actually, let me make sure I actually circle also the positive sign. So the slope is going to be -1/2 and the y-intercept is going to be 3. Now, that's going to allow me to plot this line very quickly, right? Because I can go to the y-intercept at 3, and then because I have a slope of -1/2, right, that -1 is the change in y, and I'm going to attach the negative to the 1, and the 2 is the change in x, so that means I'm going to go over 2 and down 1, over 2, down 1, and I can plot this line very quickly. I can reverse the pattern and go to the left 2 and up 1. That's sort of like putting the negative in the denominator instead of the numerator, which also works just fine. And then I can plot my line, hopefully with a nice straight edge. And I get something that looks like that. Should always make sure to label my lines with their equations. Y equals -1/2 x plus 3. Now, of my 4 examples in exercise number 2, that is the most straightforward one because I can literally see, oh, I've got -1/2 multiplying x, that's my slope. Then I've added 3 onto the end of the equation, that's my y-intercept. Let's look at one that's a little more challenging. Y equals x minus 3. Now, when I looked at my slope-intercept form of my line, it was y equals mx plus b. If I really wanted to write this particular equation in that form, I would want to rewrite it as y equals 1 times x plus -3. Okay? So this literally makes it look like this form. Now, in that case, of course, what I now know is that my slope is 1, and actually maybe I'll write it like this, is 1, which I can interpret as 1 over 1, and my y-intercept is -3. Now, if you're comfortable looking at the equation in y equals x minus 3 form and just say, oh yeah, sure, my slope is 1, my y-intercept is -3, there's no need for you then to write that down, okay? But I just wanted to show you how that general form gets reflected in something like this. So we can plot it the same way. This time though, my y-intercept is at -3, and I'm now going to want to go up 1 and to the right 1 each time. So up to the right 1 and up 1, to the right 1 and up 1. A slope of 1 is so common, it makes us just basically move along the diagonals of our squares in our grid, right? Up 1 over 1, up 1 over 1. And then results in the following line. And I know your graph's going to get really crowded after a while because you're going to have to put all 4 of these on a single graph grid. My apologies for that, but it's hard to give you more space. That's the line y equals x minus 3, okay? Now let's take a look at letter C and letter D. Keep in mind just what we talked about, right? In order to really plot a line based on the slope-intercept form, we need to have it in this format, y equals mx plus b. We've got to have it in that form. Now back in Algebra 1, you should have gotten some practice putting lines in this form in order to identify the slope of the line and its y-intercept. Let's get a little bit of practice on that in C and D. So let's take a look at C. In C, I have 2y minus 5x is equal to -2. Now, in order to get it in its slope-intercept form, I need to isolate the y variable. The first thing I will do in this case is I will add a 5x to both sides. Now the best thing you can do right now is rewrite this as 2y is equal to 5x minus 2. All right, you could write it as negative 2 plus 5x, that's fine, but given that I want the x to come first, it's always good to do that. Now, I can't have 2y, I have to have only 1y, in which case what I'm going to do is I'm going to divide both sides of my equation by 2. Now, division will distribute. In other words, I'm going to get y equals 5 divided by 2 times x minus 2 divided by 2. Okay? But continuing just a little bit farther, 5 divided by 2 can't be simplified, but 2 divided by 2 can. And so I get finally, after all is said and done, y equals 5 halves times x minus 1, which means my slope, right, is 5 halves, and my y-intercept is negative 1. And after all of that, I can now plot this line, right? Just like I did before. I can plot my y-intercept at negative 1. I now go to the right 2 and up 1, 2, 3, 4, 5. Go to the right 2, 1, 2, 3, 4, 5. And erase those so that they don't go there. I can also, well, actually, I can't really go to the left because I wouldn't have enough space, but I don't need to because that is enough for me to get a good line. And now I'll label it. Now some students will ask, understandably, should I label it with the original equation or the one I just came up with? And the answer is it doesn't matter. You can do either one of them. I tend to label it with the original equation, so 2y minus 5x equals negative 2, but it's also completely okay with you to label it as y equals 5 halves x minus 1. All right, what I'd like you to do now is pause the video, see if you can do the same thing on this particular line, get it in its slope-intercept form. In other words, I want it to kind of look like this, okay? See if you can then identify the slope, the y-intercept, and you can plot it on the same grid. All right, well, I've got to isolate the y. Now, if you're bothered by the fact that it's 6x plus 3y equals 24, you could always use the commutative property of addition and rewrite this as 3y plus 6x equals 24. Just like before, the first thing I'm going to do is move the 6x over to the other side. Keep in mind that that 24 is currently positive, so I'll get 3y equals negative 6x plus 24. Now I'm going to divide both sides by 3. Wow, that is really, really weird. I'm going to divide both sides by 3. All right, and I'm going to distribute the division. Negative 6 divided by 3 is negative 2 times x, and positive 24 divided by 3 is positive 8. And therefore, my slope is negative 2 over 1, and my y-intercept is 8. So before we plot it, let's just take a moment, right? All I've done is use properties of equality to isolate the y. Once I've done that, I can then say what my slope is, what my y-intercept is. My y-intercept is 8. A slope of negative 2 then means that I'm going to go to the right 1 and down 2, to the right 1 and down 2, etc. In theory, you should only really need to plot 2 points and then draw a line through them, right? That's where we started in this course, the idea that any 2 points uniquely define a line. But I like to have a bunch of them, because if I've only got 2 points that are really close together, that can kind of throw off my graph. But we'll do a little bit of that. I still need to label this with its equation. That's 6x plus 3y equals 24. And now I have it. All right, the slope-intercept form of a line. Probably the most useful form of a linear equation out there. It's important for us to be able to, when we have one already in this form, to be able to identify the slope and the y-intercept. Also very important, as C and D show us, when we have the equation of a line that's not in that form, we need to be able to rearrange it so that we can identify the slope and the y-intercept. Let's keep working with this more. All right, the next thing I'd like to look at are 2 simple but extremely important lines. Let's take a look at exercise number 3. Consider the lines y equals x and y equals negative x. Letter A. What are the slopes and y-intercepts of each line? All right. So I'd like you to think about that. Keep in mind, right, that we can easily identify the slope and the y-intercept if we've got lines in that form, y equals mx plus b. So pause the video now and see if you can figure out the slopes and the y-intercepts of these two lines. Well, if you really like this form, then it might be wise to rewrite y equals x as y equals 1x plus 0, in which case the slope is equal to 1 and the y-intercept is equal to 0. Likewise, for y equals negative x, we can rewrite that as negative 1 times x plus 0, in which case its slope is negative 1 and its y-intercept is also 0. These two lines, y equals x and y equals negative x, are very important in geometry. They come up a ton, right? Now, one thing I don't want you to ever forget, though, is that lines, equations of lines, describe the points that are on them, right? Let's take a look at letter B. Write down some, quote, obvious, quote, points that lie on each line. Here's what I mean by obvious. All the points that lie on the line y equals x should not surprisingly have y-coordinates that are equal to their x-coordinates. Because that's literally what that line says. Y is equal to x. So some obvious points that lie on y equal x are points like negative 2 comma negative 2, 3 comma 3, 5 comma 5. Shoot, I'll even put down the point 0 comma 0, right? All of those points are points where the y-coordinate is equal to the x-coordinate. Now a little trickier, y equals negative x, that is literally all the points on this line have y-coordinates that are negative 1 times their x-coordinates. In other words, they're the same as the x-coordinates, just an opposite sign. So if I kind of stick with the points I had up here, I would then have the point negative 2, positive 2. The point 3 comma negative 3, the point 5 comma negative 5, and I guess the point 0 comma negative 0, but negative 0 is just 0, so it would still contain the point 0, 0. All right, let's take a look at C. Graph each line on the grid. Label. All right, well, we could certainly graph these lines the way that we just graphed those previous four by saying, okay, I'm gonna graph their y-intercept, then I'm gonna use their slopes, right? But really, these are two lines that you wanna automatically know their graphs of based on these obvious points. In other words, the line y equals x, right? 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1, negative 2, negative 2, etc., right? Those are all points that lie on the line y equals x because they're all points where y and x are the same. And they're that line, right? It's that line that goes through the origin and then, if you will, kind of cuts across all the diagonals of the squares, right? So there's my y equals x. Very important line. You don't want to have to think very hard about what the line y equals x looks like. And likewise, y equals negative x, a little bit trickier, right? Negative 2, 2, that's right here. 3 comma negative 3, that's right here. 5 comma negative 5, that's down here. 0, 0's here, right? So this is almost the exact same line. It goes through the origin and through the corners of all the squares, but it's a downward sloping line instead of an upward sloping line, right? And therefore, it's got a graph that looks like this. Maybe slide it a little more up there. Actually, I'll just extend that like this, and that is y equals negative x. Also, a very important line, maybe a little bit more challenging to think about, but one that you really want to commit to memory. Now, our last little piece, right, letter D. Based on their slopes, what is the relationship between these two lines? Keep in mind, right, for y equals x, m was equal to 1, but maybe I'll write that as 1 over 1. And for y equals negative x, its slope was negative 1, but I'll write that, whoops, that didn't work out as well as I wanted it to do, right? Then here, m was equal to negative 1 over 1. So what is true about those two lines? Pause the video now and see if you can write down a single word that describes their relationship. Well, they're perpendicular, right? And they're perpendicular because they have negative reciprocal slopes. And that might be one of the trickiest negative reciprocals to see. Right, almost every other negative reciprocal is easy to see, right? 3/7 versus negative 7/3. Even things where whole numbers are involved, like 2 over 1 versus negative 1 over 2. Those are all very easy. It's a little bit harder to see that 1 and negative 1 are negative reciprocals, but it's probably not that hard to believe that that is a right angle, right? That those two lines are perpendicular to one another. Okay, so let's keep going though with this slope-intercept form of a line. Now we will work extensively, as we just saw, with parallel and perpendicular lines in the coordinate plane. So let's play a little bit around with this, given that we now have reviewed the equation of a line. Exercise number 4. Line S is shown below along with point A. Write an equation for line S in slope-intercept form. All right, so it's important for us to be able to take an equation and produce the graph of a line. But it's equally important for us to be able to take a line, the graph of a line, and produce its equation, right? So the first thing I would do here is just write down y equals m times x plus b, right? So I need to have something in that form. That's supposed to be a double-lined arrow. I'm just having a hard time with it. Okay, so I need to figure out what the slope and the y-intercept of this line is. See if you can figure those out, and then just fill in the blanks for m and b. All right, well, let's figure out the slope graphically. One thing we should immediately recognize, is that this line has a negative slope, right? That line is moving down, so to speak. And if we go over 2, we go down 1. Over 2, down 1. In other words, it's got a slope of negative 1/2. So we begin like that. Y equals negative 1/2 times x. Now, of course, we need its y-intercept, but its y-intercept is just down here. B is negative 4. So the equation of that line is y equals negative 1/2 times x minus 4. All right, cool. Let's take a look at letter B. Draw a line parallel to line S that passes through A. Write its equation below in slope-intercept form. All right, well, what do we know about two parallel lines? We know they have the same slope. So the line that passes through A that's parallel to line S will also have a slope of negative 1/2. So see if you can draw that. Go ahead and draw that line. Pause the video now and go ahead and do that. All right, well, here we go. We just need to draw some points, right, that have a slope, that are a slope of negative 1/2, given point A. So I'm going to go over 2, down 1, over 2, down 1, over 2, down 1. I can reverse that and go over 2, up 1, over 2, up 1, etc., right? And I can then connect these with a nice straight line. That should be enough to kind of get the job done. If I can get my ruler to behave. All right, and there is my parallel line. I want to know its equation. We already know its slope, right? Its slope is negative 1/2 because it's parallel to this one. The only question really is what its y-intercept is. Its y-intercept is equal to 3. And so we've got y equals negative 1/2 x plus 3. And that's it. Now, where we have parallelism, we also can talk about perpendicularity. Let's take a look at that in letter C. Draw a line perpendicular to S that passes through A. Write its equation below in slope-intercept form. All right, so again, we want to make sure that we've kind of got where A is. It's right here, and I don't want to lose that given all my work before. But now, I want a line that passes through A that is perpendicular to S, okay? So pause the video now and see if you can play around with that a little bit. Well, the first thing I really want to do is I want to figure out what the slope of this line is, right? Now, it's easy when two lines are parallel because their slopes are equal. But when two lines are perpendicular, of course, their slopes are negative reciprocals of each other. So the slope I'm looking for here has got to be, has got to look like an M, has got to be positive, and it's got to be the reciprocal, so it's 2 over 1, right? So that's going to be the slope of my perpendicular line, if you will. Now, how can I use that? Well, I can use that by then going to A and going to the right 1 and up 2, to the right 1, up 2, to the right 1, up 2. And then I can also go down 2 and to the left 1, down 2 to the left 1, etc. And then I can connect those points with a straight line. But the key there is really knowing that relationship, right? That relationship that states that we've got to have negative reciprocal slopes. Okay, there's our line. Now, we want to write the equation of that line. We already know its slope, right? Its slope's going to be 2. So it's y equals 2x, but what's its y-intercept? It's down there at -7. So that particular line is y equals 2x minus 7. All right. And think about everything that got kind of involved in this problem. We've got, parallel lines with equal slopes, perpendicular lines with negative reciprocal slopes, and then we simply have the slope-intercept form of the line. Let's do one more problem. Easy. Exercise number 5. Which equation below represents a line that is perpendicular to one whose equation can be written as 10x plus 6y equals 12? All right. Well, we know, right, when we're talking about perpendicular lines that we're talking about negative reciprocal slopes, right? And of course, it's easy to look at these 4 choices and see what the slope of each one of those lines are because they're all written in slope-intercept form. The problem is the line they start us off with is not. So see if you can play around a little bit like what we did in exercise number 2. Rearrange this line into slope-intercept form to figure out what its slope is, and then use that to try to figure out what the correct answer is. Take a moment now and see if you can figure out the answer to this problem. All right, well, let's take a look. We've got 10x plus 6y is equal to 12. First thing I'm going to do is try to subtract a 10x from both sides. That's going to give me 6y is equal to negative 10x plus 12. I'm now going to divide both sides by 6. All right, that's going to give me y equals negative 10 sixths x plus 12 sixths. And then I'm going to simplify a bit more, and I'm going to get y equals negative 5/3 x plus 2. Okay. Now, that's the line I'm starting with. I just want to know which one of these 4 lines is perpendicular to it, and quite frankly, the y-intercept is irrelevant. Just irrelevant. Has nothing to do with the problem, right? All I care about is that the slope of this line is negative 5/3, which means the slope of any line that's perpendicular to it has to be a positive 3/5, and that means choice 4 is the correct answer. Now again, I'll get some people that'll say, yeah, but what about the 2? Right? That thing has a y-intercept of -7, but that's irrelevant, right? 2 lines being perpendicular really have nothing to do with their y-intercepts, right? If I have kind of a line that's like this and it's like that, and then I have another line that's, let's say, perpendicular to it like this, right, 90-degree angle, the y-intercepts don't have to be the same. In fact, they could be the same, but it would be a little weird if they were. I mean, again, you could certainly have a perpendicular line that passes through that same y-intercept, but it certainly doesn't have to. All right, let's wrap it up, right? Today what we did was primarily review, for the most part, right? Because we looked at the slope-intercept form of a line. And that is a line that's written as y equals some number times x plus another number. The number that's multiplying x in that case is the slope. And when written as a fraction, it tells you how much the y-coordinate changes for a given amount that the x-coordinate changes. And the number that's added on at the end, the constant term in that expression, then is the y-intercept, the location where the line crosses the y-axis. Those two pieces of information are oftentimes enough to be able to plot a line without having to use a calculator or anything like that. And we want to be able to do that in geometry. We want to avoid using the graphing calculator if we can, because we'll have to graph lines rather quickly. All right, well, we'll get certainly lots of practice on that, not just in the next lesson, but going forward in many other lessons in this course. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.